Scanning electron microscopy. A scanning electron microscope is unique in that it can see objects down to the atomic level. The individual atoms that make up objects can, under the right conditions and with proper preparation, be seen. This is orders of magnitude more resolution and more magnification than a compound microscope could possibly hope to see. This is going to be able to illuminate and magnify objects that are so small that light itself is incapable of magnifying the objects. We're talking things like viruses, details, very specific details on individual grains of pollen or bacteria, very, 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 very fine detail. How a scanning electron microscope works in a nutshell is this. You've got an electron gun. You have this thing that's going to generate a very high intensity beam of pure electrons. Remember, in an atom you have a nucleus which has protons and neutrons in it. And then around it you have orbiting these electrons. They have a negative charge. You have a certain number of electrons based on how many protons you have in the first place. And the number and orientation of your electrons is really where your energy is at. Electrons are very, very high energy and intense particles. Electricity is based on the movement of electrons through a cable. So you're going to focus a really intense beam of electrons out of this gun, as light does. When you shine it, the light is going to shine in all directions. So the electrons are going to also shine out in this beam in all directions. You'll have a plate down below there called an anode, and that's going to focus the direction of your electrons. You'll have a couple of lenses that can adjust the direction of your electrons, just like if you're adjusting the beams of light, only here you're going to use magnetism instead of just a regular old optical lens. And they're going to be blasted at an object. It could be a largish object. It could be a very small object. There's very specific, technically and precise ways of preparing a specimen for electron microscopy, but it can be a variety of sizes, that object. When the electrons hit the object, just like when light hits an object, they scatter out from that object. They reflect back. You'll have a couple of detectors to pick up how those electrons bounce back off of an object. This assembly of electrons is going to be interpreted by a computer and then displayed on a screen. You do not view anything directly with an electron microscope. It has to be projected onto a computer. So this is a picture of a scanning electron microscope. It's a very large piece of equipment. You'll often have two monitors, one so you can see the largest possible image of what it is you have set up in your stage, and another one to have technical details and manipulation of the image tools. Major benefits of scanning electron microscopy is that you can see surface features that truly nothing else can. There are things that are so small that you cannot see them with light. Light is too insensitive an object to be trusting to reflect back to see it. It's just too small for that. The scanning electron microscope can see those things and see them in extreme, extreme detail. Very high magnification. Remember, your compound microscope, if you're lucky, is going to max out. You have a 10x lens and maybe you have a 100x lens down on the objective. So 10 times 100, you might have 1,000 times magnification. This will do 100,000 times magnification. Intense, very, 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 very high resolution. You can see every tiny detail on the things that you magnify. Great depth of focus. You can shift. You remember how those electrons hit your object in one place? Well, you can use that at the anode to shift where the electrons hit to all different places. The computer will assemble all of these different orientations into a very clear, sharp, three-dimensional image. Really stunning pictures. When we get into the palynology slides especially, you're going to see a lot of images of this. It can also be coupled to an X-ray analyzer to identify elements present. So when you hit objects with these electrons, you're also going to bounce off X-rays. If you add on an X-ray analyzer to it, you can detect what elements were in that object that you blasted with electrons, because the different elements, when blasted with electrons, will give off different X-rays. Drawbacks to the scanning electron microscope are noteworthy, though. It is extremely expensive to have a scanning electron microscope. Not only do you have to have people with a very high degree of training to use them, you have to prepare them very specifically. You have to get very, very special technical maintenance out to do it. They can be thrown out of alignment very, very easily. Plus, they're huge, and you have to house them somewhere. They are blasting electrons at things. This is not cheap. Police departments don't have this. Most colleges, or many colleges, don't have this. As an undergraduate, you're not going to, in college for biology or chemistry or whatever, you're not using one of these things. They're leaving this to people who are running labs, PhD students, that kind of thing. You might have one of these at a university that's affiliated with a forensics lab. You might have it at like a state level forensics lab top. The FBI certainly has a couple, but that's the kind of place that you need to be to really be able to justify purchasing one of these things. It's not mobile because it's huge. You can't stick this in your command center even if you wanted to, and it'll only produce grayscale images. This isn't really that big of a drawback, because usually if you're using a scanning electron microscope, you're looking for contour style details, and you can pick that out in a black and white picture, no problem. I mostly pointed out because a lot of these scanning electron microscopy images that you see have color in them, and I wanted to point out that that has been added after the fact. The images that are produced, and this is an old image, but look more like this, where you have shades of gray, black and white. The scientists who are doing this, these are pictures of the coronavirus, if you hadn't figured that out. The scientists that are doing this, though, they know a lot of the surface properties of them in terms of the molecular makeup of them, or they've determined it using one of those X-ray analyzers. Knowing that information, then they can go back in and color in, okay, this one type of protein we're going to color in red, a different one's going to be orange, a different one will be yellow, and we can leave all the rest gray because it's all the same stuff. And this way we can more easily visually pick out what parts are made out of what. This is really useful for your own personal, like human level interpretation of images, and it makes it really a lot more easy for the public to digest and understand what it is they're looking at.